So the skewness value with the range like -1 and 0.05, that is called as a negative skewness, and or zero point 0.5 and 1, that is called as a positive skewness. So indicate slightly skewed data distribution. So here basically we want to know the distribution of the data. If the data distributions are there, so I have created this array and converted into the data frame with the help of data frame functionality, and to ascending the value. Then I have used the skew, it gives the value 0.27. So there are -5. So it is not positive, not negative. So today I want to discuss when we have the kurtosis. It is measure the tailness of a distribution. Tailness is how often outlier occur. Maybe it is the reason for the outlier occur. Axis kurtosis is the tailness of a distribution relative to a small normal distribution. So distribution with medium kurtosis like medium tail. We can say that the mesokurtic. Distribution of the low kurtotic, we can say the plekurtic. So it is the skewness, positive and negative. Negative kurtosis, positive and normal. So if I want to do the kurtosis, like kurtosis KURT, and we have the data. If I want to work them, so try to load the data. And the age, like 94. 94 indicate the positive skewness. Positive skewness indicate the whole value in the starting. So the kurtosis, like df age dot kurtosis. So it indicate the -40, 74. So if we are talking about the what is the exact meaning of the 74. So kurtosis value can be reached 1 to infinity obviously, but generally the kurtosis value is 3. So indicate normal distribution, that is this one, and if greater than 3 then it will indicate the positive, but now kurtosis indicate the negative because less than 3, so it is the negative kurtosis, like there is no bell curve in the data is very low. So now let's see the advanced level of the statistical part. It's a very interesting to all of you, hypothesis testing. hypothesis testing. So let's see the example one by one. Theoretical, firstly to understand the theoretical concept, then we will start the practical work. Yeah, exactly. So firstly we will understand what is the hypothesis testing. So firstly to understand the hypothesis testing. So hypothesis testing, like fail to reject the null hypothesis. So it is the area if the value exists into the area minus and the plus. So it will reject the null hypothesis. So the first example I want to use the t-test. So what is the t-test? Let's see. So t-test. So t-test, a statistical test used to compare the mean. Used to compare the mean. Mean means average of group of data. Like if I suddenly take the two group of data set. So it is the library SciPy library basically used for the inferential statistical part, especially. And inside the SciPy.stat we have a function. Function name is t-test one sample. So now I want to ready the data numpy as np. So I want to ready the age np dot array 45, 62, 80. So it is just the age. You can also take the different data, but here I am just taking the different example. So now the question is that if we are just doing, so firstly I want to find out the mean. So mean, so mean just my side name like t mean or like sample mean and np dot mean and to pass the age and as mean. So it is the mean and you can say that the average of this age. But now I want to find out some hypothesis testing. So t-test and comma p value. And now I want to use this function and to pass the data and how many sample data you want to take. So I pass here 30% of the sample data. So I want to show the test value and predict. So firstly I want to check. So test value is different, but the p value is different. So the main intention, what is the p value first? Firstly to understand what is the p value. So the p values indicate, so let's see the one more example. So p value, a statistical measure used to determine the likelihood that an observed outcome is the result of chance. Like how percent of chance to come the result or the outcome. P value greater than 0, 0.5. So what is the thing like 0.5%? If the p value is greater than 0.5%, so if the p value this one, so we can print except the hypothesis. If this one, so reject the null hypothesis. So it will reject the null hypothesis because the p value is not greater than 0.5%. So we can say that the statistical measure is not determined to the likelihood that observe outcome. There is no chance for the observe outcome. And one more thing also. What is the internal logic behind this one? Let's take an example. We have the two medicine survey, and we say which one is survey is better. So H0, that is indicate the H naught, the null hypothesis. That means the survey is ground truth. If the survey is not the ground truth, so we can say that the null hypothesis is rejected or the alternative hypothesis. Let's see the one more example. So it is just a one t-test sample. So the two test example, let's see. So we have the data sample 1, sample 2. So we have the two population data. And firstly, we want to take the sample data. So it depends on us which data we want to use. So firstly, we should have the two data set. So I want to load this data for the T sample test. So we have the employee attrition data. So firstly, I want to load this data. Then we will perform some next work. So import scip.stats. So not the import from, and t test second, like ind. It is a function second two test, and it is the example of the t test one's one sample test to take the sample from the one data set. And import pandas as pd. Now df pd dot read csv, and to show the data. So it is the complete data, but we want to find out only the age. So it is the total age of the employee. So it is just a first sample t-test data. It depends on you. You can take the two different data set, and you can take the two sample from the same data set. It depends on you. So if you want to calculate the mean of this one, so you can see we have the one data set HR employee attrition, and the second we have DF. It is a DF1. So now I want to load the second data, DF2. Now DF2. So you can say that so many values are there. If I want to show the value, so there are some values are there, and if I want to pass the head 5, so there are some value. So firstly I want to fetch to find out the mean of all two data set. So like mean 1, df1 mean is pd dot like df, so it is the data mean, so not the entire df1, and to pass the age. So df1 column name is age and mean. And if you want to print data 1 mean is, so the mean is 36. It is the average age of the data set 1. Now similar df2 name is age. Like data 2 mean is, so both mean are different. So I have loaded two data set I want to discuss. First one is HR employee attrition. Second one is employee data. So the ages are different. So that is the reason. So now I want to find out the standard deviation. You can directly pass, or as per the need you can first to find out the standard deviation. So the standard deviation, so 9. So 9 is the actual variation between the date age of all the employee. Now similar, so the actual variation, the second data set is less as compared to the data set 1. So you can see we have the two data set, we have find out the variance and we have find out the standard deviation. So now I want to perform the two t-test example. So t-test and comma p-value. So now we have the function, this one, and to pass the data. So two group of the data. So first data we have df1, second we have df2. So I want to print the p-value. So p-value is p-val. So the p-value prediction value is 0. So I want to take the data first. So it is the whole data, very good. Very good. But the sample size of the data, say D1, D2. Now I want to pass D1, D2. So if the p-value is 0, so what is the mean? So I already discussed, if the p-value greater than 0.5%, so we will accept. So let's see the one diagram also. If the p-value is less than 0.001, so very strong evidence against the null hypothesis. So you can say that one more. So what is the picture behind this? So you can say that the p-value is greater than 0.5%. or you can say that 0.05. So that means we accept the null hypothesis, like there is no significance between the data. If point 0.5 up, so that no statistical significant difference. So all the mean are different. If we are challenged the two data set, and if the p value is less than 0.5%, the statistical significant difference. So that is the reason in my data set. So I hope you have understood in very well. So that is the reason my standard deviation, both mean are different, standard deviation are different. So the surveys say that the both data set age are different. So there are no significance similarity, statistical similarity of the data. So that is the reason. So what is the reason? If p val greater than 0.05, so accept the null hypothesis, otherwise reject the null hypothesis, or alternate hypothesis like H1, and you can say that the H naught. So you can say that the reject the null hypothesis. So the p value, so there is no significant difference. So the less than 0.5 statistically significance difference. So the mean are not same. So the survey same that both result assumptions are same. That means the ground truth is okay. So no, we challenge the one data set age mean are same, second data set mean are same. No, both are different. So that is the reason reject the null hypothesis.